Good morning, dear student. In today's lecture, we discuss the potentiometric practical, that is, to determine the stability constant of silver ammonia complex. So, whatever the complex which is formed, so we can find out the stability constant for this silver ammonia complex by potentiometric method. So, let us discuss some theoretical concept regarding to this practical. The complex formation between silver ions and the ammonia, it is given as like this, that is silver ions plus we required for single silver ions we require two ammonia molecules, so we get this complex, that is silver ammonia complex, in which the complex having plus one charge means the silver that is in plus one oxidation state, that is this ammonia, it is your neutral ligand. And if you apply the law of mass action to this equilibrium, to the equilibrium then the stability constant, that is denoted by symbol k, we can write it is as the concentration of product divided by the concentration of reactant. So the concentration of power of ammonia, it is 2, so we require two molecules of this ammonia. And therefore, by applying the law of mass action, we can write k, that is stability constant, is the ratio of concentration of product divided by concentration of reactant. And if you consider uh, the complex ion is very much stable, so whatever the complex which is formed by addition of the silver ions and the ammonia, it is very much stable, but it dissociate to some extent with formation of free silver ions. The concentration of free silver ion is very low. It is possible to determine such a low concentration of silver ions by forming the concentration cell without transference as given below. So this silver ammonia complex is very much stable, that is AgNH3 twice complex is very much stable, but it will dissociate to give free silver ions, and we can easily find out the concentration of these free silver ions by developing the concentration cell, such as the Ag, the silver electrode in 0.001 normal silver nitrate solution, which is connected to the salt bridge, and on other side it is the free silver ions in complex, and it is also connected to the silver electrodes. Let us consider the concentration of the silver ions in 0.001 normal AgNO3, it is your C1, and whatever the concentration of the silver ion in the complex, that is free silver ion in the complex, is C2. So C1 is known, so we can easily find out C2. So how one can find out this C2? That is, so how one can find out this C2? That is, for potentiometric technique, we used to determine the EMF, that is electromotive force of these cells, and the EMF, it is given as E, which is equal to RT upon NF ln of C1 by C2, or that is concentration of known silver ions in AgNO3, and the concentration, that is C2, that is the concentration of silver ion in complex. So C1 is known but C2 is not known, or we can write this as E, which is equal to 0.059 log to the base 10 C1 by C2 at 25 degree Celsius, where C1, so we know that where C1 is the concentration of silver ions in 0.001 normal AgNO3 solution, and where C2 is the free concentration of free silver ions in complex solution. So C1 is known, that is whatever the concentration of this silver nitrate solution is the same it is the concentration of your silver ions. So C2 can be calculated by the above expression. So you have to rearrange this equation to find out the C2. So what is C2? C2 is nothing but the concentration of free silver ions, because to find out the stability constant K, we require this term, that is concentration of this silver ammonia complex divided by concentration of silver ions into concentration of ammonia. So we require these terms. So C2 is nothing but the concentration of free silver ions in complex solution. So we can easily find out the concentration, that is C2, and the remaining terms we are easily find out with this experiment. So C2 is the concentration of free silver ions in the complex solution. So you have to rearrange this equation. All the value C1 is known, so you have to just find out the EMF for every concentration, and then we can easily find out the C2. So let us discuss the practical procedure for this experiment. Let us discuss the procedure. So first you have to calibrate the instrument, potentiometer instrument. Second, you have to prepare the cell like this, that is you have to prepare the cell, that is in one side this is your silver electrode is there, and the solution is of your 0.001 normal AgNO3, and this solution it is connected to the salt bridge, and here the solution, again this electrode is also your silver electrode, and both these electrodes are connected to the potentiometer. This is also your silver electrode, and this solution is your silver ammonia complex solution. This is your AgNO3 solution. So you have to prepare the cell for whatever the concentration you have to prepare. So let's discuss the second point. So you have to prepare this cell, that is at one beaker. In one beaker there is a silver electrode containing 0.001 normal AgNO3 solution, and in second, that is the complex solution of silver ammonia, and both beaker containing the silver electrode connected to the potentiometer. So let us discuss the second point, that is the procedure for this determination of stability constants. So we have to prepare the second point, that is you have to prepare silver ammonia complex by taking 0.01 normal AgNO3 solution and 1 normal ammonia solution in 100 ml volumetric flask. So how one can prepare this silver ammonia complex solution? So you have to take 0.01 normal AgNO3 solution and 1 normal solution of different volume and make the final volume, that is 200 ml. So let us discuss the observation table, that is solution number, it is 1, 2, 3 and 4. Then we required the ml of 0.01 normal AgNO3 solution. So in the first flask we required 10, the volume of the silver nitrate is same for all these 4 flasks. And the second, that is ml of 1 normal ammonia, so you have to vary the volume of this 1 normal ammonia in each flask. That is, in first flask you have to add 10 ml, then 20, 30 and 40 ml, and make the final volume 200 ml. So I have to dilute with distilled water. Make the final volume with distilled water. So what happened? And prepare the cell. So we already discussed, so preparing the cell, because after diluting the 0.01 normal solution of AgNO3 to 100 ml, its concentration becomes 0.001 normal. So we already discussed, you have to prepare the cell such as silver in 0.001 normal AgNO3, salt bridge, that is your C1, and the silver ion in complex, that is your C2. So after diluting the 0.01 normal into 100 ml, the concentration it changes to 0.01 normal, because one can easily find out these concentrations, how the concentration is changed of the silver ammonia complex, that is using the simple formula, that is N1V1, which is equal to N2V2. So initially the concentration is 0.01, then we take 10 ml in each flask, then you have to find out the new concentration, and the final volume is 100 ml, and therefore N2 is your we can write this as 0.01 into 10 divided by 100. So this is your N2, and this N2 is nothing but your 0.01 normal. Okay, the concentration of this AgNO3 solution. So concentration of AgNO3 solution, concentration of this AgNO3 solution. So concentration of this AgNO3 solution. So to prepare the cell, such as silver electrode is there, then 0.001 normal AgNO3 after dilution, salt bridge, and then silver ammonia complex. So whatever the solution of this complex, that is whatever the solution which is prepared after mixing of AgNO3 and this ammonia, we get silver ammonia complex solution. So at one side you have to take 0.001 normal AgNO3 solution, and another beaker you take silver ammonia complex solution, and then you have to connect the cells to the potentiometer and find out the EMF. So the solution 1, 2, 3 and 4. So let us discuss about the observation table, that is solution 1, 2, 3, 4. So for each solution you have to find out the EMF having the unit of volt. So for every solution of silver ammonia complex, you have to find out the EMF with the help of potentiometer. Then you have to find out the C2 by rearranging the equation, that is you have to find out the concentration of silver ions, because the concentration of this silver nitrate solution, the complex is known, that is we know that the concentration of silver ions in AgNO3 is known, because the concentration is 0.001, that is your C1, and C2 is what? C2 is your the concentration of silver ion in complex, free silver ion in complex. So whatever the concentration of silver nitrate, it is the concentration of silver ions in AgNO3, therefore it is 0.001, and we consider it is as C1. And whatever the concentration of free silver ion, it is considered as C2. So C1 is known, but you have to find out C2 with the help of this equation, that is we already discussed, that is E, which is equal to 0.059 log 10 to the C1 by C2. Okay, so this value is nothing but your EMF. So you have to substitute this value in this equation and rearrange this equation to find out the C2. And what is your C2? C2 is nothing but your concentration of this silver ions. So with the help of EMF, you have to first find out the concentration of silver ions, free silver ions, that is your C2. Then the concentration, that is silver ammonia complex, is given. The concentration of the silver ammonia complex for each flask is given, that is your 0.001, 0.001, 0.001, 0.001, and the concentration of ammonia is also given, that is 0.0098, 0.198, 0.298, and 0.398. And finally I have to find out the stability constant K, that is, it is the ratio of concentration of complex divided by concentration of reactant, that is concentration of silver ions and concentration of ammonia raised to 2. So how one can get these values, or let's discuss, because we know that we can easily find out this value, the EMF of the cell with the help of potentiometer. Then after knowing the EMF we can find out the C2 after rearranging the equation of E cell, and then we get this value, and after that we have to find out the stability constant K. So how this value is coming, so let us discuss about this value. That is, if you consider in the solution 1 we take 10 ml of 0.01 normal AgNO3 solution, and the excess ammonia is added to form the complex, and the solution is further diluted to 100 ml, and therefore after dilution the concentration of the complex, that is what we take excess ammonia to form the complex, the solution is further diluted to the 100 ml, and therefore the concentration of complex is 0.001 normal, and it is also true for all the solution. So whatever we discuss the concentration of 0.001 normal AgNO3, it is same concentration for the silver ammonia complex, that is N1V1, which is equal to N2V2. So we take 10 ml, that is 0.01, we take 10 ml, and we have to find out N2 and dilute it to 100 ml. So the resulting concentration is 0.001 normal. So this is the concentration of AgNO3 solution also, and this is the concentration of silver ammonia complexes also. So after diluting the solution, 10 ml silver nitrate solution of 0.01 normal, and excess ammonia is added, so whatever the concentration of this complex is nothing but your 0.001, and this is for, because we have to take same volume of silver nitrate in each flask, therefore the concentration of this silver ammonia complex is same, it is not vary with the volume of ammonia complex. Let us discuss the next point, that is how one can find out this concentration of ammonia. That is, if you consider the complex having concentration is 0.01, out of that, if you consider some of the ammonia, so not all the ammonia is used in complex formation, so you have to add excess ammonia, so some of the ammonia is utilized for the complex formation for solution number 1. So let us consider solution number 1, in which we take only 10 ml of ammonia. After that, for solution 2, 3, 4 we take 20, 30, 40, and the solution is what, diluted. So solution number 1, we take 10 ml of ammonia and dilute it to 100 ml. So the resulting concentration of ammonia is so after dilution, the resulting concentration of ammonia is 0.1. So initially again we use this formula, that is N1V1, which is equal to N2V2. So initially the ammonia having concentration 1 normal, you have to take 10 ml in the first flask, you have to find out N2 and final dilute to 100 ml. So N2 is become your 1 into 10 divided by 100, so it becomes 0.1. So the initial concentration, if you consider the initial concentration of ammonia, it is 0.1. Similarly for second flask it is 0.2, for third it is 0.3 and 0.4, like that. So if the initial concentration is known and the concentration of silver ammonia complex is known, then we can easily find out the free ammonia concentration. That is for solution 1, that is ammonia free, which is equal to ammonia initial minus 2 into concentration of silver ammonia complex. So we can easily find out the concentration. The term it is given in observation table, but how one can obtain this value, that is concentration of ammonia initial, it is zero point 0.1. So initially the one normal ammonia is used for dilution. After dilution 200 ml, its concentration changes to zero point 0.1 minus 2. So why we take 2 here? Because we require 2 molecules of ammonia to form the silver ammonia complex. Again, and the concentration of this silver ammonia complex is 0.001 normal. 0.001 normal, so it becomes 0.098. Again, similarly we can easily find out for second flask, that is we require we take 0.2 normal, because we take 20 ml of one normal ammonia, so minus 2 into 0.001, so we get this 0.198 value. Similarly you have to take zero point 0.3 minus 2 into 0.001, so we get 0.298, like that. So you have to find out these values, and finally you have to find out the stability constant. After knowing the stability constant, one can easily find out the instability constant. After knowing the stability constant, that is concentration of silver ammonia complex divided by the concentration of free silver ions into concentration of ammonia having power 2. So this is your K, stability constant. Again you have to find out the instability constant. 1 upon K can be easily calculated. It is just reverse, that is concentration of AgI into concentration of ammonia divided by concentration of this ammonia silver complex. So this is all about the stability constant of this silver ammonia complex. The remaining practicals of this potentiometer, it is taken by your Gotikar sir, and whatever the theoretical practical is there, out of that the Raman, I think Raman points, Raman spectroscopy related practical, it is taken by Gotikar sir, and one of the practical is remain, that is XRD, that is it is a table work. So in the next lecture we discuss about the table works. So we totally cover the 3 conductometry and 1 potentiometry practical, and your Gotikar sir will cover 2 potentiometry and 2 pHmetry practical along with 1 theoretical practical. So in the next lecture we discuss about the table work for this XRD. Thank you.